The Sousa Project.
By
Mikaela Parent.
Brittany Silva.
And of course, starring Mr. Chukrin and Mr. Sousa. Not pictured because I don't want my laptop to break. This is Sousa's car, a 2007 Mazda 6 sedan. This is Brittany standing on Sousa's car. These are the calculations of Sousa's car. We chose to find the length of his car, but we could have also picked the width. This is Chukrin's car. Sorry for the interruption. A 2000 Jeep Cherokee 4-door automatic. These are the calculations of Chukrin's car. The length is 181.5 inches, or 4.6 meters. The mass is roughly 1,600 kilograms. In order to make this realistic, we had to establish a scale. By taking the actual length of Sousa's car and dividing it by the model length, we were able to establish this scale. So, once upon a time, Mr. Sousa was out driving, not paying very close attention. He approached a hairpin turn, much like the one pictured. At the same time, Chukrin was out sightseeing. He noticed Sousa's car getting closer and closer. When Sousa realized he was in trouble, he slammed on his brakes, evidently skidding into Chukrin's car. This was the result. Thank God for Daigle's massive amount of manure saving our lives. No one was hurt, but Sousa never smelled the same. The speed limit was 20. But Sousa definitely wasn't going 20. How do we know? We'll prove it. First, we'll start by calculating the projectile of Sousa's car off the cliff. In order to prove that Sousa was speeding, we need to find his initial velocity. And to do so, we use the equation x equals vxt. But what does t equal? Let's use the second kinematic equation to find out. Taking the distance of the cliff drop, which is a negative displacement of course, and knowing that the car was at rest, with the constant acceleration of negative 9.8, we were able to find the time. The time came out to be 2.84 seconds. And when plugged into our initial equation, Sousa's velocity came out to be 6.59 meters per second. It went a little something like this. What are you doing?
Our man drives too fast into the corner.
Next, we have to find the impact velocity of the collision. By using the law of conservation of momentum, we were able to find the velocity. The impact velocity came out to be 12.3 meters per second. The last step to proving that Sousa was speeding was calculating the length that his car made with the skid mark and using it with the law of conservation of energy. Pi equals Pf. Initially, the car was moving. As it was skidding and coming to a stop, it had kinetic and thermal energy. By rearranging the equation, we were able to find the speed at which Sousa was traveling at before he hit Chukrin's car, which turned out to be 34.8 miles per hour, which is approximately 15 miles over the speed limit. In conclusion, Sousa was traveling 35 miles per hour.
We hope this house.